boa tarde, boa noite aos internautas que nos acompanham neste programa Nanotecnologia do Avesso, hoje no seu número 454. Fazemos este programa dedicado ao público não especialista, porque é este público que paga as pesquisas sobre nanotecnologia realizadas no Brasil. Também fazemos este programa porque é aqui que nós podemos discutir os impactos da nanotecnologia na sociedade, no meio ambiente, na economia, na ética, no direito, na saúde, coisa que não são discutidas aonde se faz nanotecnologia no Brasil. Por fim, fazemos este programa porque acreditamos que ser livre é ser bem informado e a divulgação científica contribui, colabora para o aprofundamento da democracia e da cidadania no Brasil. Hoje, conforme tínhamos anunciado, estamos conectados com o professor Zhang Lin Wang, diretamente da Escola de Ciência de Materiais do Georgia INSTITUI, diretamente da cidade de Atlanta, nos Estados Unidos. Eu vou pedir a ele, ele vai se apresentar e depois começar a apresentação do tema de hoje. Ok, doctor, could you please introduce yourself about your experience with nanotechnology?
Okay, first I'd like to say a few words that thank you very much for giving me this opportunity to talk to the broad audience in Brazil. And myself went to graduate school in 1983 in the US. That time I was doing nanotechnology research, but it was not called nano at that time. And I have my thesis here. I hope you can see, read the letter. That time called small metal particle. Well, today we call nanoparticle. That time called small particle. Basically, it was nanotechnology. So I finished PhD in 1987. Around 1990, 91, people started work on nanotechnology. So I have a long history of research in the field, and our researchers can bring a lot of exciting things to which could change our future way of living. So I want to give you some update. What do we do related to energy, sensors, robotics, and artificial intelligence? So in that case, I will switch this slide to my presentation. I'm currently a Regents Professor and Hightower Chair at the School of Material Science, Georgia Institute of Technology, and I'm also the Director of the Chief Scientist in the Beijing Institute of Nanoenergy and Nanosystems in China. So I direct that institute as well.
Okay.
So let me switch to my presentation for the shared screen. Let me see. All right. So can you see the screen right now?
Yes, very well.
Okay. So I will just present the things we have done in the last few years. So my recent research was started. I was become a professor at Georgia Tech in 1995. This was almost 24 years ago. So when I first started, was doing the transmission electron microscopy study of nanoparticles, which was a continuation of my PhD thesis. And later on, around 2000, we discovered the oxide nanobelts. And since then, around 2005, we discovered the piezoelectric nanogenerator and proposed the idea of nanoenergy as well as self-power system. By year 2012, we started triboelectric nanogenerator, and then later on we found this is a tremendously important area which can provide a new way for power generation. I think it'd be particularly useful for Brazil, for area that need a small energy for power, small things, which is our technology could be a very good one. We also developed a lot of electronics called piezoelectronics, piezophotonics. Those areas I have been working for many years. So this gives you a brief view of my particularly my career path in the last 25 years since I become a faculty. So in that case, let's talk about the recent things. And when we do research, we focus also not only on the fundamental, but we also focus on what can new technology can bring to the society. What are the new products we can produce, and what are the future we can impact? So my research should be somewhere like a tree. Why do a tree? If the left-hand side you see is nano-generated based nano energy and a cell power system. On the right-hand side you see is piezoelectronics and piezophotonics based electronic system. All this has been done in the last 12 years, and which has a worldwide impact. So let me show you some of the early day work. When I become a professor, I was on nanotechnology. That time was working on a carbon nanotube, and this nanotube is very tiny to see, very little tiny to see. So we use transmission electron microscopy to see that. So we build a holder, want to measure the mechanical, electrical property of individual nanotubes. So as a result, we can see it, and we can measure the mechanical strength of a carbon nanotube. This was 1998, 1999 work, and but it started the field of nanomechanics work. Okay, so that was the starting point of from imaging to measurements. As you see, this carbon nanotube is about 6 micron length, with about 1/10 of a hair width. The diameter is very small, is about 10,000th of a hair width. So very small. We try to measure the mechanical property of those nanotubes through this resonance technique. And later on, we put a gold particle at the end. We can measure you can see the gold particle. We can measure the mass of the gold particle to 22 femtograms. So those are the early day work, almost 20 years ago. And until 2000, we discovered the oxide nanobelts. We fabricate nanomaterials, and we can produce the nanobelts ourselves. So this can be a new materials for discover new electronics, new photonics, as well as energy technology. So which was a new adventure from our career. So this was around 2000. Okay, and we can grow all kind of nanomaterials, and this is one of the things we grow is zinc oxide. We grow line arrays, and this can be twice on the front coverage of the national report for nanotechnology. And those are the areas we work on property measurements. But this leads to the discovery of what I'm going to talk to today, called nanogenerator. So what is nanogenerator? Back to 2003 or 4, we tried to use atomic force microscopy to measure the mechanical property of those small, tiny little entities. And so we use an AFM tip to scan across those wires. And that time we tried to measure the mechanical property, but also the piezoelectric property. So what we got that time is that, okay, if this is a piezoelectric, what is piezoelectric? Is a material that give you a voltage once you press it. Okay, simply say, and this is called piezoelectric effect, but it only occur for specific materials. So we use a AFM tip to trigger the wires and receive only very small power, 5 millivolts. 5 millivolts was very small. This was the beginning. As I wrote this article, you can see nanogenerator, and this has become very well received today. And also in this article, we raised the idea so-called self-powered. And so what is this about? How do I understand this? So let me explain to you what do we mean by self-powered and nanogenerator as well. So this, you see, this picture was took in 2005. This is 13 years ago. And me and my students finished experiment. We had a lunch, and that was around time here, 2005. We never thought this work would be lead to establish 2 major important fields, and around the world there's 2,000 people follow us now to do this research. 35 countries, and also have 130 units doing this research with us right now. So that time we just published a paper, but we never thought we go this far. But we do have the hope that time say this will be a great field. So we persistently work on this until today. Okay, so let me show you what are the exciting things we do. So every country needs energy. They need a large-scale energy for a city, for a country. They also need a small energy. As you see on the left-hand side, there's a lot of small electronic. Today, everybody has a cell phone, right? Everybody has a cell phone. But based on cell phone, there's a lot of sensor unit distributed around. Gas sensors, chemical sensors, biological sensors, medical sensors. Each of this one need a small power. If there's no power, there's no sensor. That means that regardless of what we made, we must have a way to measure the signal. So it have to be powered. So this become a bottleneck for very many different things. So therefore, whatever we made, we have to be power. We have to have power. So what is the power for these small things? That was my research for last 12, 13 years. Okay. So then you say, if you have these small powers, for what? Okay. The application can be for medical purposes. You can do medical device powering, or you can do patient monitoring. A lot of patient monitoring need the sensors, robotics need the power to operate. Also for environmental monitoring, because I bet like Brazil have such a big land, you need the water quality tracking, forest safety, fire protection, everything. You need a lot of sensor widely distributed. So environmental. Today's the other one is the Internet of Things. People want to be hook up everything with internet, but without a small power, you cannot make it the Internet of Things. So in other words, if you rely on a battery to drive the Internet of Things, 90% of the Internet of Things will be impossible. So that means you cannot make it work. So we have to be solar powered. That means what? Harvest energy from our living environment. Also, asset tracking and structure monitoring. You have a lot of bridges, infrastructures. How do you know the safety of those buildings? Is anything happening? We need to monitor, and as well as the, of course, national security applications. So all of this one need billions of trillions sensors, and you have to get them powered. Battery is a good choice, but it's not the best choice, because 90% of those things will be impossible if you use battery. You send the people to change the battery, maintains, track the battery, very much work, a lot of work, and eventually make this will not be feasible. So I proposed the idea 2006 that can we make things self-powered? Self-powered means what? Can you harvest the energy from the environment to make it work itself? For example, if you have a sensor near me, when I'm talking, sonic wave is the energy. Can we harvest the sonic wave energy to power the sensors? If you have a biological system here, and can you use the biofluid, the energy harvested from biofluid, to drive this? Is this possible? So we thought about all these possibilities and try to make sure these things can serve our future. So this is called self-powered technology. Today is very well received and worldwide working research in this direction. Okay, what are the energy available? We look at a human. A human has a lot of energy. We can walking, tapping, breathing, whatever. Those carry number of watt of energy. If we convert them into electricity, everything social human can be powered by those energy. Just like walking, you can get 11 watt. Just blood flow, you can get a fraction of watt. Finger tapping can a fraction watt. All this can be useful for small things. So how the question? How are we going to do it? How can you use body motion to harvest the energy? So this is what I'm going to talk about. So the first example we'll utilize is called piezoelectric effect. So what is piezoelectric effect? You see, some materials, when you press it, you generate a voltage. And when you release it, this voltage being released, the present of this voltage here drive the electron will flow back and forth. So electron will flow back and forth when you apply a strain and release the strain here. So this is called piezoelectric nanogenerator, right? Which is very good. Let me show you a couple examples here. As you see here, we put on a finger edge, around here. And when the finger moves, can generate small power. You can see this finger motion here.
Yeah.
Okay, you can see the finger motion here generate AC current. So those ones can be utilized. Then we integrate this into many wires, not just one wire, very many wires. We can build an integrated device. We can give about 100 microampere current and 50 volts. So those things start to be useful. So we talk about the power level of 1 to 2 milliwatt, and sometimes get 10 milliwatts, and this become useful. So in our research, we utilize 3 effects for power generation. Today, I mainly talk about a second effect called triboelectric effect. So what is triboelectric effect? Everybody is familiar. Triboelectricity. You get up in the morning. For example, you handle your hair, and you brush everything. That's triboelectricity. But this one we knew for a very long time. But how can you effectively utilize this one? Become very challenging. We see thunderstorm, right? Thunderstorm is a triboelectricity, but it's very complex to understand the phenomena. Until 6 years ago, we started to build a way to utilize the potential generated by triboelectricity for power generation. So how do we do it? Let me show you a couple of this animation here. This was invented in 2011. We made 2 pieces of polymer, put on the finger edge, and the finger motion generated about 3 to 5 volts that time. This was the first work on the triboelectric nanogenerator. And since then, we made a gigantic progress in this basic theory, technology, and applications. Okay, so let me explain to you what this is about. Okay, if you have two dielectric, they contact one with the other one, and the triboelectricity occurs at the interface. At the interface, then you see, once this interface occurs, on the top of the bottom electrode, you have the electron to flow from back and forth. So when you do this, back and forth, you're going to have the charge flow from one electrode to the other one. So this is a power generation. As you can see, a small hand tapping of a 1 inch size can immediately lit up about 20 to 30 LED lights, which was impossible before. So this simple motion here, using triboelectricity, can lit up a light. So this is the first mode, called the contact separation mode. And you can make this generator use organic materials, transparent materials, so you can put on screen, people can see it. Okay. Also sliding. Okay, you can see sliding, and once the sliding here is also triboelectricity occurs. So when you slide them apart, electron has to flow. And again, this can be used like for power generation as well. You can see this we demonstrate this sliding back and forth, right? Sliding back and forth for the light. So just simple motion like that. Okay. So this is another effective way to convert mechanical energy into electricity. Okay. There's other mode here we call single electron mode. You can say 2 pieces of materials, one scrubbing another one. You get a little power output here. You can see that. That's just a simple motion here, and they're gonna sliding this up top. See that? You see the light flashes, right?
Yes.
So this is the you can generate electricity, but Previously, you can never be this easy to generate electricity. Okay, so there's a few modes. We want to cover all the motions in our life, because we can walking, sitting, automobile can be vibrating, driving, wind can flow, anything can happen. It's all mechanical energy. And I bet Brazil have a lot of people, and people's everyday life is a lot of energy, such that our technology allow you to convert this into small powers for specific purposes, as well as sensors. So let me illustrate you with some examples. Okay. Then you say, what are the material can use it for? Say, well, does this need expensive materials? The answer is no. We can use general materials, use aluminum, paper, you know, all the piece of paper we utilize. This is good triboelectric materials. Okay, and wood, silk, cellulose, polymers, all this can be used for that. So you name it, our shirts, fabric can be used for that. So therefore, the choice of materials is low cost, diverse, and available. So no wonder so many people interested in this one. It can be widely utilized in very many different fields. So therefore, this is the choice of materials. Okay, they say, what you do? Okay, we improve the surface materials to make the function better for our purposes. So we can introduce some nanostructure on surfaces and patterning on surfaces, so it can be the enhanced output order of magnitude, right? So compared to flat surface, we do the surface functionalization and the patterning, we can make it function much more better. So this is, we do that for surface engineering. Okay, then you can make all kind of generator. You can see, you see this is a transparent made, shoe insole, plastic, disc, cylindrical, fabric, everything, you name it. Each of these one is a small power generator, and it can be utilized for two purposes. Number one, power. Number two, mechanical sensor. So let me illustrate that you with some examples here. Okay, examples. So this is just the basic we could do.
Yeah.
Utilize triboelectricity. Walking, right? Everybody's walking. We can make it into the shoe insole here, and just it does not add any weight and does not any discomfort. Is a power generator. You can charge your cell phone by this. So therefore, if you go outside, you're out of power. Then here is a way to convert body motion energy into electric power, right? That's just with us all the time. We walk all the time. Plus, every day we have to walk some distance for exercise purposes, right? Okay. Wind, you can blow a wind just through this nozzle here, can generate a low power. Oh, sorry. Okay, let me show you the video.
Yeah.
You can see the video.
Yeah.
It's showing here, right?
Yeah.
Just blow a nozzle through here, through our system here, is a power generator. And if you can, this the half the wind energy. You don't need this wind turbine. The wind turbine is very expensive. Each turbine engine is $1.5 million. Very expensive, very expensive. But plus, if you don't have a certain degree of wind, that does not work. So this is used. You can put this on the air conditioner system, inside the pipe, anywhere you want to be. Okay, then, okay, medical. You know, some of the people use pacemaker for heart purposes. We can use the breathing of an animal to drive a simulated pacemaker. So we don't need to replace the battery once a while. So the pacemaker can be self-powered. Is this a wonderful thing? It's for medical purposes. Power supply is a big issue. So for pacemaker, we can make self-powered pacemaker. Use the people's breathing to power it. And this is only possible utilize our technology. Okay, raindrop. Okay, This just show you medical, but we do a lot of brain stimulations, drug delivery, very many things use our trouble generator. We can make this biodegradable, biocompatible, and easy to use. Easy to use. For water drop, I think that in Brazil there must be a lot of water draining, right?
Yes,
Okay.
but we have many problems to use the water for transform in energy, because he have big dams. It is put many problems.
Okay, look, our technology, we do not need to build a dam. Let me show you. Okay, this is the water droplet come from the sky. They can liquid and a solid surface can cause a contact electrification, and then you can see, if you can see this video, we're just wobbling the surface of water a little bit. You're gonna see the light flashes. Do you see light flashing?
Yes.
Okay, so this is use the motion of the wave. Okay. Then the second video show you this is you have a shower head.
Yeah.
You shower head and just drop a little water on that. You can see power generated.
Yeah.
Okay, why do you need, in a traditional technology, why do you have to build a dam? Let me tell you the reason why they have to do it. Okay. Okay. So this just show you the way to do it. Okay. We use thin film. We make a thin film to do that. And this thin film sliding can 50% efficiency for energy generation. Just plastic. You can see this one. Do you see this little plastic?
Mm-hmm.
It's a power generator. Convert mechanical energy into electricity. Let me show you. And you can see just sliding back and forth.
Yes.
Those lights are crazy. This is something you are unable to do before. Okay, so our technology, our nanotech, make this possible. Okay.
Mm-hmm.
Now comes your question. You have a lot of water, but you have to build a dam. Why? Have you ever thought why the dam has to be this high? Never.
Yes, but I think there is many reasons about the problem with the dams. One reason is about our government. Every year think that we have to increase our development, and for increase the development you have to have more energy.
Right. Let me show you a way to do this differently. Okay, because if you want to build a dam, it cannot be built in everywhere. It's just only in a specific location you can build it, right?
Yes.
Also, and there's a lot of people have to migrate to other places, and their home has to be taken away for that.
Yes, this is a big problem.
The dam has to be about 100 meters or something in height. Otherwise, they cannot generate electricity. Why? The reason because they have to drive the turbo engine run fast. If you run slow, it won't work. Let me show you one example. I have a little toy in my office. Okay. Do you see this? This is a little toy in my office. Do you see that?
Uh-huh.
And there's electromagnetic generator here. Okay. So if you do slowly, the light does not flash, right?
Uh-huh.
Until you do fast. Do you hear that?
Yeah.
That means the turbo engine has to run fast in order to generate electricity. If you run slow, the voltage is not enough. But use our technology, you can do this one. We can make a trouble generator as like a sphere, like a tennis ball, Inside the sphere, and these things enclosed in the water. Inside, there's a core rolling back and forth. If you have floating water, now you see this. Do you see a little ball here?
Yes.
Floating? the light flashes.
Mm-hmm.
As long as motion, power is generated. This uses our technology. This technology was invented in 1831, 180 years ago.
Long time,
Okay. Yeah, but the power is designed for that. Now if you use ours, just floating water. You don't need to build a dam. Just any river, anything, just anything, lighting, fluctuate. That's it.
Yeah.
You literally have power everywhere, anywhere you need. It's self-sustainable. Just use natural motion, right? It does not burn anything. It does not cost any kind of fossil fuel, right? Okay, how do we do this? Let me show you an example. If we make a sphere like this one, how about this? We put in the ocean, put in the river, whatever the motion is, make a network. And all this network, as the nation move here, you can generate a little power. How much power you can generate? I did a calculation. For area of 400 kilometer by 400 kilometer, 10-meter depth water, if you build this networking, like I show here, the power output is enough for the entire world. Let me say again, 400 kilometer or 400 kilometer area, 10-meter depth water, the power generates enough for the world. This works day and night. You don't need to build a dam. You just build this floating on the surfaces. Can you see that?
Yeah.
So this is my dream, called Blue Energy Dream. I'm developing this right now. Hopefully one day we can bring this to humankind for energy. There's plenty of water around, but the water energy we rarely utilize.
Yeah.
Okay. So why? You say why here? The reason because the classical technology is a good technology, just like I show here. Inside here is this magnets. This inside have magnets, and then the power output is the frequency to the square. But our trouble generator is what? Is surface effect. So when you have a lower frequency, this is the function frequency, the electromagnetic generator cannot input any power, output any power, because it runs too slow. Can you imagine that? This thing runs slow. There's literally no power. You have to. Why? Have to run fast. If you run fast, it means the frequency goes up. Ours works very best in low frequency. So this is a technology that we just discovered about 6 years ago. If we knew these kind of things, let's say 100 years ago, it can change the world design in many things, right? And you can utilize low frequency energy everywhere. Low frequency everywhere. Human walking, human talking, human actions, our muscle motion is all low frequency. We cannot utilize this before. Like a river, water flow, all low frequency. We cannot utilize this. We just have the classical technology. We have to use the other one. But now we have a choice. We have a choice. This is only possible through our research. Okay. So that was just show you from an energy point of view. Sensors, you know, anything is a trigger. A trigger become electric signal is a sensor. As I show here, this is a water droplet drop from the top and trigger the nanogenerator become a sensor. Very little tiny force, a few milligram weight, very little. And this is a sensor. We can utilize for sensor. We can sense everything for security sensors, motion sensors. We can utilize for touch sensors, touch screen. You know, cell phone, touch screen. in the future be used for this touch screen, right? Many things we can utilize trouble electricity as a sensor. Okay, like here, we make a matrix 6 by 6. You touch every part, it give a signal itself. Rather, you don't need to supply power to this. It just give a signal itself. Can you see the letters flashing?
Yes.
Okay, that means self-generated signal. And this one you put on our side. You don't need to supply power. It is generated by self once being triggered. So you have people walking, triggering. This is called self-power sensors here. Okay. So NANOGERADOR has very many different applications here. And it can be a small power for drive small things. Tiny little power. Because we're going to have very many different things in the future, right? We want to be monitor chemicals, gases, temperature, humidity, everything. We also have a lot of things on the blue energy, energy from the water, from the ocean, from a river. We never be able to utilize that. We don't have to build a dam. Now we can utilize this. So this is the blue energy. And sensors. You know, everything sensor. I just show you a trigger sensor, a touch sensor, you know, flat panel display sensor, all needed this one. Can be made by our NANOGERADOR. So I have 3 major applications: small power, big power, and sensors. You can see all these things from our research has been demonstrated. So we are this one. And I think this research fits Brazil very well. Why? Large population, huge land, and also the infrastructures may not be as advanced as other countries. They need power. They need a lot of advanced technology. Plus, low cost, available, diverse around your living environment. So you can see, and for this one, and we can have very many different things to offer. So how good you can do this one? We can generate a power density from, this was a few years ago, to the best of by 500 watts per square meter. Square meter, we can give the maximum 500 watts. What a gigantic output. What's the efficiency? We can easily achieve 50% efficiency. A lot of things can be offered. So therefore, this thing is fast expanding. And we wide around the world, 2,000 people follow our pioneer work to do this. Is because it's going to be very useful. Be very useful for that, right? So this is a way we talk about the nanotechnology. Let me go do a comparison. When I show you this, you may not see very well, but this one you're going to see. You're going to see? Did you see this video? Did you see this video?
Yes.
Yes. On the left-hand side, you see there's a electromagnetic generator. You may be familiar with that, right? On the right-hand side, you see our triboelectric nanogenerator. Do you see the two have to run at different speed?
Yes.
The electromagnetic generator has to run faster, only lit up 2 lights. Ours rolled at a slower speed, run immediately lit up to 30, 50 lights. That's the difference at low frequency. So at low frequency, our performance is much more superior than the classical technology. So therefore, it could be very different ones. But these two technology is complements one with the other, not replace one with the other one. Okay, complements. How come? Let's see. The two are from very different ones. Electromagnetic generators is called electromagnetic induction. It has a high current, a low voltage, high efficiency at a high frequency. They have to run fast. Ours technology is high voltage, lower current, high efficiency at low frequency, low cost. So both are different and built on based on different principle. So they can be utilized in a complementary way. And based on very different principles. So how come different? Why do you call nanogenerator? So let me show you the reason. So if we talk about magnetic field and electric field, both are equivalent. We know that's equivalent. If you have magnetic field, you have electric field. You have electric field, you have magnetic field. It's through the Maxwell's equations here. So we invented electromagnetic generator. Okay, this was done 1831 and a long time ago, 180 years ago. But ours utilize the so-called Maxwell's displacement current, a different one. Utilize the time variation of magnetic field and electric field. So we build a piezoelectric generator and a trouble generator, and inside is run by a so-called displacement current, and outside is called conduction current and a mid electrode. Regardless of all these details, both are different branches. You can see left branch and right branch. Those are our technology can do. Okay, so very differently, new discovery. So look at the future. When Maxwell put up the displacement current in 1861. Yeah. This is a long time, 150 years ago. 150 years ago. Later on, he predicted electromagnetic wave, light theory, antenna, radio wave, telegram, wireless communication, all the cell phone technology based on this today, right? But there's another term in the equation was ignored until 2 years ago. I found this. This is the medium change, which is the principle of our piezoelectric generator, nano generator, trouble nano generator, can be the energy for our new era, the energy for big data, sensor network, Internet of Things, very many different things we care about today. So I personally anticipate a lot of advances in the field, in the future, in this one. Right? There's a lot of advance in the future of this one. So hopefully we can bring something to impact people's life in many different ways, right? In many different ways here. And so I think that's what I just like to talk. Then left some time we can discuss and debate and how about that?
Yeah. Oh yes. Yeah.
Okay.
Very good.
For the students who are interested in this technology, this book can be useful.
Very good.
Yeah.
I learned more things about with your presentation. I don't have in-depth knowledge about this subject. I have some general questions for you.
Yes, please do.
Okay. So my first general question is about the many examples is for small things. Yes. Is small things, but we live in our country, in United States here, that the concentration of the power doesn't like the small things.
Yeah.
So
that's correct.
The companies like the big things. One of the reason we have big guns is because many companies are interested to building another big dams. We in Brazil have all day of the year we have many sun. So many people think that we have to develop the solar electricity, but the solar electricity is in small things. No, so there is no help from government to develop this.
Solar energy is a great energy part, and nowadays they have well developed as commercial product available, and and it can integrate panel by panel. You can make very many different arrays for power supply. But the big thing with solar energy is that it can only be a supplement amount. It cannot be the major part. The reason because it's not stable enough.
Okay.
So you have sun, you have no sun, you're raining, you have day, night. So it's not very stable now.
Yes, but in the increase in the storage.
Yeah, storage.
Yeah.
You can storage and utilize. That's a good way to do that. And so the solar energy is important part of energy. Solar energy, wind energy, all
Yes.
supplement green energy.
Yes.
The energy I talk about from human motions here is energy for the small things in the future.
Okay.
But you can integrate that into array. Say sphere here, sphere here, sphere here. You can make an array into a network, like a fish network.
Yes, I agree. I agree with you. But the politicians here in Brazil, the government, doesn't like this kind of a way to put more energy. Because the pressure of the big companies.
You know what? You don't need to put in a lake, because lake is for people to do leisure and everything, right? But in the ocean, a little further away from the coast.
Yeah.
Have a very in that case, there's no boat, not on the track of the path of the ship, but also complicated underwater environment. You can put on the surface water for that kind of things, right? So we talk about a comprehensive package of energy solution for the world. No single technology can solve it. We need the solar, we need the wind, we need our troubled nano generator. We also need a classical electromagnetic generator, all put together as a solution.
And you think that the nuclear energy is also necessary?
I think so, because nuclear energy, because does not occupy too much land, is stable and is necessary. But of course, people worry about the safety. And I know I was in Germany, Japan. People worry about the safety. But I think it's improving. People like in the Asia country like China, Brazil, those countries, they need energy. Where are they going to go? Well, has to be nuclear power plant.
Yeah. And my another question is about you talk about the costs. I would like to know more about the costs of the product. Also the cost to do this kind of research.
Let me tell you two ways, okay? Number one, the cost for doing research in this one is real low. You don't need a $1 million equipment. No, just simple equipment. You can do measurements, you can produce data, and to do research. For application, these materials available. We use plastic, we use organic materials, metal foils, anything we can have, maybe harvested materials, we can utilize that. So there's a calculation about the materials cost is lower than solar energy, lower than nuclear energy. Pretty much all the energy, the cost for this one is lower.
Okay, and how many people is in your team to do this kind of research?
I have about totally under my direct supervision, I have about 50.
50. Okay, so it's a very big or not big, I don't know, but
yeah. I think I hope to see more people in Brazil to do this kind of research, because the infrastructure does not cost very much, and also there's new direction, new field, new application, and it does not need a sophisticated equipment to do it. Number one. Number two is truly have a lot of broad application in what we're looking at. So therefore, with these two, suddenly the worldwide is the effort. I'll just read a proposal from Europe today. There's a group team put together a European project on this, and they just try to develop tribology nanogenerator for some other applications.
Yeah, but here in Brazil, the problem in general is about the funds. There is no funds to do this kind of research.
Well, in this case, the government that they have to realize they needed to invest in the education and the future technology. And at the same time, they also, you can try to send some Brazil students to other places, worldwide exchange program, and they can learn more about that. I think as a country, science technology is critically important, has to be put in one of the top agenda of the country, because everything our quality of life improves because science technology.
I agree with you, but here, happy. Our politician doesn't like this.
Well, let's say I bet the politician, each of them use cell phone. Let's take their cell phone away, and because that's the result of scientific and technology development. It's not the result of politician.
Yes.
Right. See what they think.
And the politician also eat, and he have many increased research in the fields of production foods. So the politician eat all day, but doesn't see the importance of to put money to develop more science and technology for new foods or new energy.
You know why? Because they are major. They probably just studied degree in law or politics, philosophy or something. They probably are not a graduate from engineering college or science college, right?
Yeah. So
that's the problem.
Yeah, this is our...
Same in the United States. Nobody but talk about science.
Okay. Thank you so much for your contribution to our program. I hope in a near future you have more things to talk for us about your research.
Absolutely. Yeah.
Okay.
Thank you very much. Give me this opportunity, and I will hope next time we talk to you about our new advances in different areas.
Okay. Thank you so much.
Okay.
Bye bye.
Thank you. Bye bye.